Alright, hello everyone. My name is Timothy Lee Grant and welcome back to another video of engineering investigation. So in this series, what we do is I try to go and find different topics within engineering, different concepts that I don't quite understand, and then we just investigate them. Try to become better engineers, try to improve our skills and understanding. So that's what this is about, just chill kind of series where we just go and see what we don't know, see what we can find out. So let's start up. Today, what I think I am going to try to figure out is, okay, when I have a C# application, I know that I can publish it. And when I publish it, what happens is I get a whole bunch of files, like DLL files, and then I'm able to take that large folder in the publish and just paste it over to a different machine and then just run the executable. How does that, what are all of those other files? How does this, I want to kind of understand that a little bit more. So that's one of the things that we're going to investigate. So let me come here and I'm going to make myself a little bit smaller. And so I have my Visual Studio up here, and we'll do some C# there. Now, let's just start by asking Copilot. So I want to understand more about how publishing in C# works. All right, let's see what it has to say. Okay. There we go. So, where is it? Here. All right, publishing in C# means packaging your application so that you can run outside of the development environment. So it has all of the dependencies. So I don't need to do all of those includes or make sure that I have all of my files. It should just come along for the ride. You can publish using Visual Studio or the .NET CLI. You can choose between different modes like framework dependent or self-contained. Okay, so I like the self-contained because that means that I don't need to. I actually don't know what it. I just do self-contained, but I don't know why. That's actually a perfect question for these videos is, okay, well, what's the difference between framework dependent and self-contained deployments? I don't know. I just do the self-contained. I just know that it's a little flag that I do when I do what a .NET publish and then the architecture that you want and then it's like a -- self-contained. But I don't know what it is. I previously was just trying to get it to work, you know? And I made a video maybe a couple days ago about what I view the difference between a junior engineer and a mid-level engineer. I defined a junior engineer as someone who is much more focused on just trying to get the product to work. They're trying to get their task accomplished. But the mid-level engineer is different because they are going to be much more concerned about what is the underlying concepts and do I understand those underlying concepts. And because I'm trying to transition from junior to mid-level, that's something that I'm being very aware of. Okay, so what does publishing mean? Publishing is the process of turning my source code into a distributable application. So another question that I'm wondering is, okay, if I publish something, does that actually mean that the person that I give this folder to, are they able to get my source code? Okay. And then the other thing, let me write down these questions. What was the first one? What is the difference between these ones? This. That's follow-up question number 1. Follow-up question number 2 is what? if I have a distributed publish, does that mean that all of the other people have my source code? Okay, that's follow-up question number 2. Follow-up question number 3 is going to be, what are the same concept as publish for C# in other languages such as Python, C, Java, and JavaScript? Okay. So far, that's our follow-up questions. We might get more as we read through here. So what does publish mean? Publishing is the process of turning your source code into a distributable application, okay? It involves compiling my code, building required libraries, and optionally including the .NET runtime. Okay, so that actually, the .NET runtime might actually be this difference between framework dependent or self-contained. So if the system that I'm putting my software on does not have a .NET runtime, then it's not going to know how to execute the executable. Okay, so that's why I need to publish the entire thing, the self-contained, and it includes the runtime. I believe that's the case. Okay, but we'll find out with this follow-up question. I will say for follow-up question number 4, what exactly is the .NET runtime? Okay. Publishing modes. Okay, so there are 2 main approaches in modern .NET Core 5, 6, 7, etc. Framework dependent and self-contained. Okay, so it kind of is answering the questions anyways. Let's see what it has to say, and then maybe we include that question, maybe we don't. So for framework dependent deployment, FDD, your app depends on the user having the correct .NET runtime installed. So now we need to worry about which version. So .NET Core, .NET 5, .NET 6, .NET 7. Okay. It has a smaller package size because we don't need to include the .NET runtime, I guess engine maybe. And so an example publishes DLLs, there are those DLLs that I was talking about, or executables that runs with .NET Run. So you can do the command .NET Run, and then that will spin up the project, and it knows what to do because it's on your local machine. It's the engine that fires it up, okay? So now, if we do self-contained deployment, it includes the .NET runtime natively to the publish folder. So it's larger because it has that .NET installed. Okay, that makes sense. And there's a single executable file. Yes, that's true. Okay. So now how to publish. Visual Studio. I'm not on Visual Studio. .NET CLI. So this is the one that I normally do. Is .NET publish, and then you can do the release, okay, and then the architecture, and then the -- self-contained true. So that's how I normally do it. Release build. R is target runtime Windows 64, okay. Bundle the runtime. All right. So distribution options. Easy deploy for Windows. Okay. Folder publish just a folder with all binaries. Use zip and share. Okay. That's fine. Okay. Things to keep in mind. Dependencies. External DLLs or native libraries must be included. Okay, so if I am trying to use an outside library. Okay, so let's follow up question number 5. How do I do this? Give me an example. Okay. Target runtimes, you must specify the architecture. Yep, that makes sense. Update self-contained apps. Need... okay. There we go. While it's doing that, I'm going to have a sip of coffee. Okay. We have a lot to go through, huh? Okay, so framework dependent versus self-contained deployment. So framework dependent, your app depends on the user having the correct well, we already went through this actually. That we're not going to worry about that. Distributed, publish, and source code. No. Okay, so that's interesting. So we don't have access to the source code. It's just the executables and all of those like files. Publishing does not mean you're giving away your source code. Publishing produces compiled binaries, the DLLs or executable files, okay? Others can run your program, but they don't see your original C# source code. However, compiled binaries can be decompiled, reverse engineered, with tools like ILSpy or .peek. That's interesting. Okay. That's why some developers sometimes use obfuscation to make reverse engineering harder. That's actually kind of cool that you can do reverse engineering. That's cool. Okay. Equivalent concepts in other languages. So you can distribute .py files, the source code, or packages into wheels. Okay, we've seen wheels before. Now, I've used wheels, never successfully. I've attempted to use wheel files in the context of I wanted an offline system and I had an external online system. So my laptop, okay, I can give it a real example. Okay, so here's a Raspberry Pi. Can you see it with the light? Anyways, Raspberry Pi. Inside of here, there lives a computer that does not have access to the internet. Let's just pretend I don't want it to have access to the internet, okay? Now, on my laptop that you guys are seeing right now, this one does have access to the internet right there. See? So I can take this Ethernet cable right there, plug it in here, okay, and then plug that to my computer and then do something like WinSCP, and I can throw files to my Raspberry Pi, which is not connected to the internet. So I can download what I was wanting to do, download files, libraries from my online computer, send them over to the Raspberry Pi, and that way the Raspberry Pi doesn't need to connect to the internet. I don't need to do the sudo apt install. I don't need to do any of that. It's already self-included. And when I was looking into that, I ran into those .whl, the wheel files for Python. Although, unfortunately, I had never gotten them to actually successfully work. That being said, what a perfect opportunity for us in this video to look at wheel files. I say that every time I come into a concept that I don't understand or that, I previously have looked at, but, it's not something that I have a comprehension of yet, I take a little bit of a note. So here we go. Let's, Python, WHL, wheel files. Okay, so we're gonna be looking that up. And I just wanted to make a note so that we didn't forget. Okay, so for standalone apps, you use tools like PyInstaller or bundle Python dependencies into an executable. So I can use PyInstaller, some software, bundle it together. Okay, sure. C and C++. You compile source code into native binaries, executables on Windows, ELF, Linux. Okay, yeah. So talking through this a little bit more, I'm realizing, yeah, okay, here is definitely one of the differences between like compiled languages and scripting languages like Python, where C and C++ are compiled, and so there is going to be that layer of self-containment, kind of, I think. So for C and C++, publishing means distributing the compiled binaries and any shared libraries. Okay. DLLs or SOs. In Java, you compile to .class files, then package into a jar or war. Once again, we did see this when going through Java, and this is something that's kind of interesting. Like, when I was first going through Java and I was making the Java tutorials here on YouTube, not really tutorials, but it was me building a project, but I didn't know anything about Java. That was kind of the intent of that video series, is me learning Java and going through the process. We actually saw those jar files, and I remember working with them, and so I didn't understand, like I didn't have a more holistic comprehension and understanding of what they are, what they're doing, why they're important, what their connection is to publishing, all of this. Now I'm starting to, okay, now we come back to it from a different angle, and we get a much more rich understanding holistically. So it's really nice. Now when I go back to Java, all of a sudden I'm going to start with a huge advantage and head start, because I know from multiple different angles what's going on with this jar and war. And so it's nice to be able to make connections. All right. The user needs to have the Java virtual machine, and I think the Java virtual machine is similar to the .NET runtime. I believe that they are similar. So for JavaScript, let's see, for Node.js apps, okay, yeah. So with JavaScript, the language is only able to run within the browser. So web browsers use JavaScript. So what if you want to run it outside of the browser? You have to use an engine that allows you to be able to communicate with the hardware of your device, and that is Node.js. Node.js is the engine that takes the JavaScript code, translates it, and is able to do those system level API calls to your hardware to perform those operations. So you can run JavaScript outside of the browser. So for browser applications, you can bundle. Okay. Whatever. What exactly is the .NET runtime? All right. What exactly is the .NET runtime? The .NET runtime is the environment that executes and compiles C# code. So I think it is very similar to the Java. Oh, there it is. I was reading. Yep. Here. It is. Okay. So it includes the common language runtime, manages memory, garbage collection, etc. Exceptions. Base class library provides core API, collection, IO networking. Okay. In Python. Okay. So, next one. Including dependencies, DLLs, native libraries. When publishing, you need to ensure external libraries are included. Okay. So, newtonsoft.json. So we need to include this. And we have our program here. And this is an external file. So it's somewhere else. It lives somewhere else. Okay. Now, what we can do, how do we publish it? You can install it via NuGet. Okay, so NuGet is similar to like pip and npm, Node Package Manager, and what was the Java one? I forget what the Java one is, but it's the packet manager. That's the other thing that we need to remember. One of the other things that I'm confused about is how do you actually, I wrote it down. How do you take something which is published on GitHub? So it is just, I'm just going to say unassociated code. It's just there on GitHub. It's in folders, right? But it's not associated with a like NuGet or pip install or npm. So how do you take that code that you see online and how are you able to use that as a library? That's a question that I have, and I want to investigate it in this video as well. So we have what we're doing right now. We need to do Python wheels, and I want to understand that, what I was just saying. Okay, I already have that note, so I don't need to write it down again, but we're going to do that in this video. So, .NET add package. Okay, so we're able to just go in and just add the package and then do publish. Okay, so what I'm thinking right now is this command, the .NET add package, that must take this newtonsoft.json, put it into my folder somewhere, and then when I do the publish, it just comes along for the ride. Is that the end of this? Okay, so yeah, I'm gonna say, so when I do this, there will be files added to my project, and then when I do this one, those files will come along for the ride. Like that. Okay, let's just verify that that is a true statement. Okay, so exactly. There we go. Whew. Kick the table. Alright, so this command adds a NuGet package reference to your project. What actually happens? So I have this csprod file gets a new package reference. You know what? I don't want to keep reading. Let's do this. In Visual Studio. Okay, so I'm gonna come here and is it strict? Do I have to name it the same? I want to see if I can do this. Okay. And then paste. I want to see. I'm purposefully doing a ridiculous name here because I know Java script, or sorry, not JavaScript, Java would be very angry at me for doing this. And I want to see if that's the case here. So I'm going to come, so we do this, it's an external package. So now I can get the command line. Is it, hold up, actually, maybe I forget. Is it .NET Run? Or do I need to compile first? I think I need to compile. Couldn't find a project. Yeah, okay, so what is the compile one? How do I compile and run my C# on a Mac? Okay. I forget the commands. And then we're a little bit scattered right now. We still need to go back up. But I wanted to just kind of build. Here we go. Okay, so .NET new console. Okay. And that generates the CS proj file. Okay, here we go. So let me actually come in here. I have this practice 1. I'm just going to delete this actually. Delete. Move to trash. Okay. And now I'm going to do .NET. What was it? New console. Okay. Minus N is going to be ASDF. Okay. So now we should, when we run this command, we should see program.cs and we should see .cs proj. Okay, so let's run it and let's see. Okay. So now we come here, program.cs, and we have this cs proj. Okay, so now let's change directories into this here, and I can just do ls, and we should see, there we go. Okay, so now what I want to do is I want to go into this program cs here, and then paste in there this program. Okay, now what I should be able to do is .NET build. Okay, so .NET build. Could not be found. Okay, so we needed to install it first. It's complaining because we haven't installed this one yet. Okay, so .NET build. Yeah, the world is in order. Okay, compiles the code. Awesome. And we can't compile it yet because we don't have that file. So we need to do the NuGet capturing. So .NET add package. Okay, here we go. Come on. Come on. Almost. There we go. There we go. Nice. Okay. So now I should be able to come here and I can also move Copilot, this one, this, and then that gives me a little bit more room to scoot it over. So I can do .NET add package and then new Newtonsoft.json. Okay. Should be able to get that. And let's see what it did. Okay, so when I do this, my CS project file. Oh, this is like the. Oh, what was it called? In Java, we had that. Oh, what was it called? There was a file that had all of the packages that we needed. I forgot what it was called. But let's go check out this one. Okay. Yep, and here it is. Package reference include here and then the version. Yeah. Just like the one that we met in the Java investigations or projects. Okay, so when we do that, the packages itself, the DLLs and metadata is downloaded onto the NuGet cache under this folder. Okay. It's not copied directly into the folder. Instead, your project knows the reference. Okay, okay. Building the project. When you run .NET Build, the compiler links the code against the Newtonsoft DLL from the NuGet cache. Your app now depends on that DLL. .NET Publish. This command creates a publish folder with everything you need to run the app, which includes the executables, all referenced NuGet packages, okay, and other dependencies, and the runtime itself. So it just looks at this file here and says, oh, I need this NuGet package reference, and then gets it. Okay. I am starting to see. Okay. So now I do this, and now I should be able to do .NET Build, right? .NET Build. Okay, build successful. That failed previously. Awesome. Okay, and now I should be able to do .NET Run. .NET Run. Like this. There we go. And it's in JSON format, so we know that we did it right. Here we go. Let's go. All right. Woo! Okay, so we got that. Publishing optional. Okay, so now let's just publish it. Let's publish this. Okay. So I'm going to just copy what they're doing here. I'm going to do .NET publish, and then C, I'm going to say release. Now R, this is the architecture, so OS X, and we are x64, I think. We wouldn't be 82, so yeah, x64, not 32, right? Yeah. Self contained is true. Ding 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 ding. Let's see what is created. There should be a publish folder at the end of this. While it's doing its thing, I'm gonna take a sip. Okay, so all right, we got a whole bunch of stuff, but I am not seeing a publish folder. Oh, okay, so bin, it should be in here. Bin, release, publish. Here we go. And we should be able to just copy and paste all of this. And this is just like the binaries and all of that. So that's what the No, do not put a breakpoint there. So that's what the DLLs and all of that are. They're just like binary files and okay, fine. Look at all the files that's needed for just like this very simple software or program. Okay. Awesome. So on Mac you can use Visual Studio for Mac. That's fine, I don't care. What was the next thing? Okay, so Python wheel files. So let's can you tell me more about Python wheel files? And so I want to be doing more projects with my Raspberry Pi, but actually I tried to hook it up to my Mac and it was working in my last video, the one that I was doing with the Raspberry Pi. I was able to SSH into it and I was able to communicate with it, but all of a sudden I'm not able to get any. It's like it's not even connected at all. So I need to figure out how to connect it to like a monitor. I don't have the whatever micro USB, if you can see it, but I don't have the like micro USB things here for actually connecting it to a monitor and seeing like, does it come up? I don't even know if it comes up. Does it come up? What's its IP address? What's my IP address? What's the default gateway? Like, I need to go and try to figure out like, okay, well, why is it not communicating? But I can't do that because I don't have the cable to be able to see it. So fine. But yeah, once I get that up and running, I want to practice with these wheel files. That is definitely an upcoming video, is practicing with wheel files. Absolutely. Okay. But for right now, what I'm going to do is I am just going to look at it and try to get a high level conceptual idea of, okay, well, yeah, this is what a wheel file is. This is how they work. This is the direction that I'm going to be heading for when I actually practice. Hold on, let me take like a 10-second breather or something. Almost done. Almost done. Okay, let's get back to business. So, a wheel file is a built distribution format. Okay, so that's what it is. It is a built distribution. So we're building a Python package. It's essentially a zip archive of a specific structure containing PyC and PyD files, okay? Metadata like, so it contains not Py files, but PyC and PyD files. I don't know what those are. Oh, just compiled Python code. Whoa, hey, look at that, compiled Python code. So that indicates to me that the wheel files need to have some understanding of which architecture they're going to be put onto. Like, what hardware architecture? Is it going to be like my Mac architecture? Is it going to be a Linux distribution? Is it going to be a Windows distribution? Is it x86? Is it like ARM? Is it like what is it? Okay. So when I run pip install and then the wheel file, Pip unpacks the wheels and registers it. No compilation step needed. Awesome. While wheels are useful, so speed. Installing a wheel is much faster than building it from scratch or from source. They can be tagged for specific OS architectures, so like Linux or AMD 64. Okay. Consistency ensures users get the same pre-built binary, reducing errors. Yeah, okay. So, pure Python wheels contain only Py files, work on any platform. So not PyC, but Py files, okay? Platform wheels contain compiled extensions specific to the architecture. Okay, yeah, that makes sense. Now, let's see. So if you're developing a package, you can build a wheel with pip install build and then Python im build. Okay. This produces both a tar GZ source distribution and a wheel file. Then upload these to the place that pip install gets all of the packages. Suppose you want to install NumPy from source. Pip downloads the tarball, compiles the C extensions slow. From wheels, it downloads NumPy, all of this .wheel, and installs instantly. Alright, well, I said that I wanted to get to the other one, which was like how to take a GitHub repo that's not associated with any kind of like manager and get it on and running in your project. But I'm a little bit tired right now. I think I'm going to take a little bit of a break and then come back, and I'm going to be making more videos today. So if you want to follow along on this journey, subscribe. I would love to have you along, and I will see you in a little bit once I take a small break, and I'll be right back. So anyways, thank you guys for watching. My name is Timothy Lee Grant. Have a wonderful rest of the day, and goodbye.